Yo, what's going on, Scholars? This is Mr. McCaffrey, and we are going to be doing test exam number 3, corrections. So going to get out your exam, and we're going to go over all the problems from exam number 3, and this covered chapter 1. All right, so let's go ahead and start right here. So it says graph the function using transformations on the coordinate plane below. So we're going to be graphing this parent function, which is actually a quadratic. This power of 2 means that it's going to look like a parabola, a quadratic, on this scan right here. So let's first start that. It says label at least 5 points, and we're going to graph it. All right. Well, if we remember here now, our vertex, okay, is going to be in this form right here. So if you have a times x minus h squared plus k, well, my vertex is always going to be hk. So if I look right here, my vertex is going to be the opposite sign of 3. So that's going to be negative 3, 4. So I go over 3, 1, 2, 3, 1, 2, 3, 4. So that right there is going to count as my vertex. Okay, so it says right now to label 5 points. Okay, so I have 1 point right now, and that's the point negative 3, 4, right? So if you are aware of the shortcut does this. You always go over 1, up 1 times a. So my value of a is negative 1. So over 1, up 1 times negative 1 is negative 1. So since it was negative, I'm going to go down, though. Okay, so there's another point, and then do the other side. There's another point. And then I go over 2, up 4 times a. But my a is negative 1, so I go over 2, up 4 times negative 1. Since 4 times negative 1 is negative 4, I'm going to go down 4. So there's a point right there, and there's a point right there. And it says label at least 5 points. I have 5. So this right here is enough information for me to graph this guy right here. So let's go like this. So that will be this dude. Sorry, it's not really straight there. Ah, that's horrible. That'll work out right there, though. Okay, that'll be it. All right, so here's my parabola. And so that takes care of this right here. So I just labeled 5 points. So let me just go ahead and just label what they are. So this is the point negative 2, 3. That's the point negative 1, 0. That's the point right there, 1, 2, 3, negative 4, 3. And that's the point negative 5, 0. So this is what I wanted to see. I wanted to see that you labeled, put the points on there, and you're able to label them. Notice that I put arrows at the end here. You actually lost a half a point. You didn't put arrows. Arrows mathematically mean that they go on forever. Okay? So that's why I got to keep going down there. Okay, so we already know what the vertex is. Negative 3, 4. The x-intercepts, well, look, negative 5, 0, and negative 1, 0. So the x-intercepts are negative 5 and negative 1. The y-intercept, well, I didn't continue the graph, but watch this. If I continued my shortcut, if I went over 3, I go up 9 times, let's see, 9 times a. Well, a is negative 1 again, so I'm going to go over 3, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it really is going to cross right here. So that's going to be my y-intercept of negative 5, okay? Give the intervals in which the function is increasing. So when it says give the interval when the function is increasing, we're only going to look at the x-axis. Okay, so what interval on the x-axis is the graph increasing? Well, we always start from left to right. So if I start from left, it's going to start way down here, right? So from way down here, how far are we on the x-axis? Well, not at negative 8, but we would be way over here, right? So we're going to start at negative infinity. So starting at negative infinity, okay, so starting with negative infinity, watch what happens here. If I go from left to right, it's going to go up, up, increasing, and then bing! Where are we at on the x-axis? I'm at negative 3. So from negative infinity to negative 3, I'm going to be increasing. Notice I use parentheses, which means that the number is not included. At 3, I'm not going up or down. I'm just staying still, so that's why I put an open parenthesis. Now, when are you decreasing? Well, that means I'm going to start back up at -3 and look, and go down. So that would be from -3 to positive infinity, because as this goes down, the x-axis just keeps going further to the right. Domain again means what values of x did the graph use to graph it? Well, it's going to go forever to the left on the right, forever to the right, or to left and right. So my domain will be all real numbers. What is the range? What values of y did it take? Well, it's going to go on my range. Will go from -infinity, from all the way down here, because see how this goes on down forever? But then it's going to go up, and it stops at a y value of 4. So then there you go, at 4. I notice I'm going to use brackets right there because the 4 is included. Okay? Coming down here, what does the function have a relative maximum or minimum? Well, this right here has a maximum. And my maximum, so I'm going to say right here, this is 1 point by circling that. And what is it? It's going to be 4. Look at the y-axis. So here, if I draw a dotted line right here, that's the maximum number that our quadratic will go to. It can't go any higher than 4. Okay? And what is f of 0? So that just means replace x with 0. So my function again was f of x equals negative x plus 3 squared. What was it? X plus 3 squared plus 4. So f of 0 just simply means replace x with 0. So 0 plus 3 squared plus 4. Well, 3 squared is 9, right? This is 9 times negative, so that's a -9 plus 4. And that means right there, so when I plugged in 0 for x, I'm going to get a -5. So this is the point 0, -5. And if I come over here, don't I have the point 0, -5? See that there? So basically all we're doing right there is we just showed what the what the y-intercept was. All right, and last but not least, plug in f of x plus 5. So replace x with x plus 5. So I'm going to take this and plug it into x. So f of x plus 5 equals, again, replace x with that. So negative, I'm going to replace this x now right here with x plus 5. X plus 5 there. See? I replaced this x with x plus 5. Plus 3 squared plus 4. Simplify all this. So I get x plus 8 squared plus 4. If I expand this, that means negative x plus 8 times x plus 8, and then plus 4. Doing the FOIL, I'm going to get x squared plus 16x plus 64 plus 4. I just use brackets. I don't know why. I could use parentheses. Let's distribute that negative sign. So I get negative x squared minus 16x minus 64 plus 4. And last but not least, the grand finale full answer, minus 40. And don't forget about the x there. That is a 40. Okay, so this will be my final answer right here. You miss points if you didn't simplify it all the way. This is the most simplest form of when you plug in x plus 5.